In order to do the next section on trig identities, we have to remember some of our fraction operations. So we're just going to do a skill review. When you multiply fractions, you really multiply straight across. There's a reason for this, but we don't have time to go into that. But that just means you multiply the numerator and denominator. And what I like to do is reduce first. So for example, I can reduce or cancel these 5s, even though they're not directly on top of each other. A 5 divided by 5 is 1. It's called the identity property, so I would get 6/7, and that's all I can do with that fraction. It doesn't matter if I have letters. This z will cancel this z because they make a 1 when they divide. Left in the numerator is an x, 5y in the denominator. And now what we're going to do is the same operator with trig. So when I'm dividing, I see this sign. Notice the angle is the same as well. They would cancel each other. So my answer would be the cosine of x. Now I like to put parentheses to isolate my variable x. These would only cancel, in this case, if this angle was matching. If they were not matching, they would not be the same and not reduced to the value of 1. Division is just like multiplication, but you multiply by the reciprocal. And a reciprocal is, I'm going to rewrite this, 2/3 divided by 6/5. That's what this bar means. And so I'm going to take 2/3, I'm going to change this into multiplication. I get to multiply by the reciprocal. So again, what I like to do is reduce this fraction. So it looks like the 2 and the 6 would cancel, leaving me a 3. So it's 5/9. This again is division. So I can rewrite the problem as 2x over y divided by 6x over z. Turn it into multiplication by multiplying by the reciprocal and looking, it looks like these x's would cancel each other. 2 goes into 6 3 times, so in the top I like to make my letter z with a slash through it so it doesn't look like a 7 or a 3, and in the denominator is 3y. And again, here is your divide, so I'm just going to repeat this process on trig. This divide. Now the question might be, what is this 2 located right there? Well, that's just a square. So in exponent terms, that means that you have 2 of them being multiplied. So I'm going to write both of them down, and it's all over 1. So now I'm going to cancel, and it looks like cosine x over cosine x would equal to 1. So the only thing I have left is a sine of x times a cosine of x. So what I did was I just reduced that division problem. Addition is a little bit more time consuming because you have to make sure when you add, you have to have common denominators. So let's look at it in terms of numbers. This denominator is the same. So I have 2 of the 9 pieces, 4 of the 9 pieces. I now have 6 of the 9 pieces. I cannot reduce prior to adding these. I can reduce now if I'd like to, but you can't reduce before because you're adding. And you need to have this idea of 1, which is division. So if I look here, keep my denominator, I have 6 of those x pieces. And likewise with trig, I keep my denominator because it matches, even the angle must match. 1 plus 2 is 3. Now the hard part comes when they don't have matching denominators. So 3 and 9 don't match, but if I multiplied 3 by 3, I can do that if I multiply the whole fraction by 1. 3 over 3 is a fancy 1. It's the one I need to make a 9 in the denominator. Again, I have to add those up, and I get 11/9. So we can leave it there. Looking at this next fraction, I have an xy, and I have an x. So it looks like if I multiply by a y, they will match. And I can do that if what I do in the denominator, I do in the numerator, because this fraction is equal to 1. So I get 2y over xy, and I like to order them alphabetical. And I have 4 over xy, so adding them, I have 2y plus 4 over xy. Notice the denominator just carries along. You're going to be doing this with trig, so it works the same. I have no matching here, but I think if I put a sine of x here over a sine of x, I've multiplied by 1. It's called the identity. I can multiply by 1 in any case. And over here, I'm going to multiply by a 1 that is cosine of x. And I chose cosine of x because that's what I needed to make these two denominators match. So I just see what am I missing, and I put that in terms of a 1. So now cosine times cosine is cosine squared. That's where we write the little square. 1 times sine is sine x, and the denominator is cosine x, sine x. Now lots of people will try to cancel. You cannot cancel anything in this fraction. If I was to cancel a sine, there is, yes, a sine in this piece of the numerator in the denominator, but there is not a sign. It's missing in this one piece of the numerator. So there's no way you can reduce that fraction. So in doubt, I would say don't reduce, just leave it, and you're probably pretty safe.